Hi everyone, this is Subhashni. Today my topic is data reduction. Data reduction is a technique ensures the integrity of the data while reducing the data. Data reduction is a process that reduces the volume of the original data and represents it in a smaller volume. Data reduction techniques are used to obtain a reduced representation of the data set that is smaller in volume by maintaining the integrity of the original data. By reducing the data, the efficiency of the data mining process is improved, which is produces some analytical results. We have some techniques in data reduction. We have mainly 5 data reduction techniques: dimensionality reduction, numerosity reduction, data cube aggregation, data comparison, and discretization operation. First one is the numerosity reduction. Numerosity reduction eliminates the attributes from the dataset under consideration. Thereby, reducing the volume of the original data, it reduces the data size as it eliminates outdated or redundant features. Here, we have 3 methods in dimensionality reduction. One is wavelet form, principal component analysis, attribute subset selection. The first one of in a dimensionality reduction is wavelet transform. In the wavelet transform, suppose a data vector A is transferred into a numerical different data vector A bar such that both A and A bar are vectors of same length. Then how is useful to reducing the data because the data obtained from the wavelet transform can be truncated. The compressed data is obtained by retaining the smallest fragment of the strongest wavelet coefficient. Wavelet transfer can be applied to the data cube and space data or Q data. Next one is principal component analysis. Suppose we have a data set to be analyzed to have tuples and attributes. The principal component analysis identifies k independent tuples and attributes that can represent the data set. In this way, the original data can be cast on the much smaller space and dimensional reduction can be achieved. Principal component analysis can be applied to the space and skewed data. Next one is attribute subset selection. The large data has many attributes, some of which are irrelevant to data mining. The core attribute subset selection reduces the data volume and dimensionality. The attribute subset selection reduces the volume of data by eliminating the redundant and irrelevant attributes. The attribute subset selection ensures that we got a good subset of original attributes even after eliminating the unwanted attributes. The result probability of the data distribution is also close to plausible the original data. Next, second technique in data reduction is numerosity reduction. Numerosity reduction reduces the original volume and represents in smaller. We have 2 techniques in numerosity reduction. One parametric, second one is non-parametric. First one is parametric. Parametric reduction incorporates source only data parametric instead of the original data. One of the method of the parametric numerosity is regression and log linear method. Regression and log linear method is linear regression models are relationship between two attributes by modeling a linear equation to the subset. Suppose the linear function is y equal to double x plus b. Next one is non-parametric. A non-parametric numerosity reduction technique does not assume any volatility. The non-parametric technique results in a more uniform reduction irrespective of data size, but it may not achieve high volume of data reduction like parametric. At least we have 4 types of non-parametric techniques: histograms, clustering, sampling, data cube aggregation, and data comparison. Histograms. A histogram is a graph that represents frequency distribution which describes how often a value appears in data. Clustering. Clustering technique groups similar objects from the data so that the objects in a clustering are similar to each other but they are dissimilar objects in another cluster. Sampling. One of the method used in data reduction is sampling, as it can reduce the large data set into much smaller data sample. We have some n tuples decontained set, sample random with replacement, sample random without replacement, clustering sample, and stratified sample. Next one is data cube aggregation. Data cube aggregation, this is a technique used to aggregate data in simpler form. Data cube aggregation is a multi-dimensionality aggregation that uses the more aggregation at various levels of the data cube to represent the original data set. The data cube aggregation is a multi-dimensionality aggregation that erases the multi-dimensionality analysis. We have a data aggregated data year 2020, 2019 and 2018 sales, having quarters sales. These years data are aggregated in a one table. Here 2018 sales, 2019 sales, 2020 sales. Next one is data compression. Data compression employs modification, encoding, and converting the structure of data in a way that compresses less space. Data compression involves building a compact representation of information by removing redundancy and representing data in binary. Data can be stored successfully from in compressed form is called lossless compression. And next one is lossy compression. We have two data compressions in data compression. One is lossless compression. Next one is lossy compression. Lossless compression encoding the techniques allows a simple and minimal data size reduction. Lossless data compression uses the algorithm to restore the precise original data from the compressed data. Lossy compression. In the lossy data compression, the compressed data may differ from the original data but are useful enough to retrieve the information from them. Here we have a diagram. Original data. The compressed data we get original data without lossless. From the compressed data we get original data approximately, that is loss. Next one is discretization operation. Discretization operation technique is used to divide the attributes of the continuous nature in data with intervals. We have two approaches: top-down discretization and bottom-up discretization. First one is top-down discretization. If you consider a one or a couple of points to divide whole set of attributes and repeat this method up to end, this process is known as top-down discretization and also known as splitting. Top-down discretization, if you first consider all the constant values as a split points, some are discarded through the combination of neighborhood values in the interval. This process is called bottom-up discretization. Last but not least, benefits of data reduction. We have some benefits of data reduction. The main benefit of the data reduction is simple. The more data we can fit into the terabyte or disk space, the less capacity we need to purchase. Here some benefits of data reduction, such as data reduction can be save energy, data reduction can reduces your physical storage cost, and data reduction can decreases your data center time. This all about the data discretization. Thank you guys.